Hello again and welcome to An Idiot Codes, episode 3. Now last time we covered things. Things are great, games are full of things, but what games are more full of is moving things, which is what we'll do today. Now to start with, let's do a crash course on what we covered last time, which is adding something to the game. We'll start off adding the content itself. I created two lovely little cars earlier, let's add those, and now they're in our content. We want a new game object. In this case, we want a game object to be a car. Then we need to load this content. Come down to the load content area. Follow the pattern of last time. A car equals a new game object. The car dot sprite file equals content dot load pointy bracket texture 2. I can't spell texture 2D. Then we refer to sprites 00 and car.position equals new vector 2, and just for simplicity's sake let's put it slap bang in the middle of the screen. So we want viewport rectangle dot width divided by 2, so it's all the way across the screen divided by 2, right slap bang in the middle. And vice versa, viewport rectangle dot height divided by 2. So now that's right slap bang in the center of the screen. Come down to the bottom, draw it like we did last time. Sprite batch dot draw car dot sprite file. Right, now things get a little more interesting because we need to add a little something extra. Whereas last time I had just one rectangle which said where we want to draw this one image. This time, because we're using a file that has two cars in it and we only want to use one, this is what's known as a sprite sheet. It can be used for animation, it can be used for making simple objects out of lots of different pieces, it can be used for making maps and so on and so forth. So we need two rectangles this time. One to decide on what part of the file we need to be looking at, and the other to say where that needs to be drawn on the screen. And as you can see here, the order goes, where is it? So the first one is the destination rectangle, where we want it to be on the screen. So new rectangle car.position.x car.position.y. Then it wants the height and width of the car, which in this case will be 100 and 100. Later on we will take these attributes and make it a lot more straightforward where we just need to decide this once and it'll all filter through, but for the moment, just to get it on the screen, this is what we'll do. And what we need now is the source rectangle. In this case will be a new rectangle. Now the car we want is at the very top left of the sprite sheet, so 0, 0, 100, 100. And of course again, these need to be integers rather than floats because things are weird like that. And if we press play, we have a car right in the middle of the screen. That is a very simple recap of what we covered yesterday. Super speed, just to get a new car in. Next we're going to add the attributes into it which make it a moving car, as all good cars should. So how do we go about adding motion? Well, first thing we need to do is add one or two things to the game object class itself. We know where things can be and we know what they are made of. We have a position and a sprite file. We need two more things which will help us give motion of various types. The first one is a new vector 2, which again is just two values. They can be used for anything, but at this point it's just one value and another value, as you've seen. And we'll call this one velocity. Velocity is different from speed because it entails a direction. So, for example, if the vector 2 was 1, 0, that means directly right. There's no vertical component, just a horizontal component. I'll show that in action in just a moment. And we also want a public float, which is a number with decimal points, and it's not a whole number, but it can be, but it's not. And we want that to be rotation. So then we come into game 1 again. We come to the update. We finally get to add things to the game that actually work. So what we first want to do is car dot velocity equals, and we can say new vector 2. Let's say we want it to drive forward. At the moment it's pointing up the screen, so we want that to be 0, no horizontal movement, -1. And because these are floats, you need to put well, you don't need to, but it generally behooves you to put a decimal and the letter F, so 0.0f. So now the car has a velocity of -1, which in this case is up the screen. The higher the second value is, the lower down the screen it is. -1 is up the screen. The car dot rotation, in this case we don't want it to equal a value, we want it to have a value added to it, so it's plus equals 1.0f. Again, it's a float, 0.0f. And then we want to make sure the velocity actually affects the car, so the car dot position has the value of the velocity added to it. Now, just to make sure the rotation actually comes into effect, we need to add more to the draw call. So car, you see now we've got a much longer list of things that affect the car. We're only concerned with rotation, but we still have to fill in these others. So car dot rotation. The origin is where the center of the car will be. In this case, that's right slap bang in the middle of the sprite. So new vector 2, 50, which is half the height, and 50, which is half the width. Sprite effects, we don't want any of those, so dot none, and 0, because everything is on a flat panel at the moment. Now, if the magic happens, the car will go up, and it will go in a bit of a spin. Let's see. Well, that is quite a spin. Maybe not quite so fast. So we can crank that right down to 0.05. There we go, we now have a moving car that is skidding off into the far end of beyond. So that's the most basic part of a moving thing. From here you could put conditions that choose where the velocity goes, where the rotation is. You can make it so the rotation is attached to the velocity. In fact, let's see if we can do that. Attaching the rotation. Right. I think it's better to have the rotation be the thing that determines which way we're facing, so let's have that decided first. Let's bump that up here. Now this velocity we've got at the moment doesn't really matter, but we'll keep it for posterity. We'll comment it out with 2 forward slashes, like the to-dos and things. It just means this is now just text. It's completely ignored as commands. It doesn't affect anything. That's all we need it to be. Now things get a little bit mathematical and a little bit mind-bending here. It took me a few moments to work out exactly what I needed to do, but I'll try and talk through it as best I can. Right, so we want car.velocity to equal some aspect of the rotation. So we need to convert the rotation, which is currently like a clock face. It's just a value going round in a circle, like round and round and round. Here's 0, 0, well, 0.0f, and then round to like, I imagine the bottom would be 180.0f, and again like a circle, and it'd work in that fashion. But I'm not entirely sure. This is what I managed to get to work. So we want the velocity to be a vector 2, but we need to extract a value out of the rotation. And we want that value to be consistent. So we will normalize it. I can barely spell, but that's alright. Whatever result we get from this will come out as 1, like a standard unit. So then we'll be able to times that by a speed at a different point if we want to speed the car up, slow the car down. This is just about moving to a direction. From there, close that, because everything we open we want to close. We need a new vector 2 that is based on, stop doing that, float of math.sine, trigonometry to the rescue, car.rotation, then float math.cos car.rotation. Now what this does is converts, like a triangle, it takes the line and makes it a horizontal component sine and a vertical component cosine. They need to be floats in the same way that the other things needed to be ints, and everything just needs to be the specific thing. I don't know why it doesn't do it automatically, but I'm sure if it did, the world would explode or something equally horrific. We break this broadcast for an emergency mathematical explanation. Now, since I wasn't doing a particularly good job of explaining that, here's a little diagram that should help make it a little easier. The information we have is the angle that the car is moving, in this case car.rotation. What we need to know is how much of that is moving in the x direction and how much of that is moving in the y direction. If we take the sine of the angle, we get that x component. If we take the cosine of the angle, we get that y component. That's all that little thing does. Hopefully that makes it a little bit clearer, but probably not. So now the rotation will slowly increase and the car should drive around in a circle. Well, crumbs, that's I think I know why that is. It's rotating the opposite direction to its going. That may be because in the weird world of programming, with the top left being 0, 0 and everything that moves down is the positive number, the vertical thing should be negative. So the further down it goes, the higher it gets. If you reverse that, then you're moving in the right direction. If you try that now, yay, we have a little car that's driving around in a circle. A very tight circle. It's quite impressive. Handling like that, well done. Let's see if we can slow that down a little bit and get a slightly wider circle. Yeah, that's fine, that's grand. So we've got a car driving around in a circle. And that is the very, very basic approach to moving things. Next time, we'll try and apply these same systems to a moving thing that the player controls. As I said in the first episode, the only thing we can do at the moment is quit the game. But there's a little preview of the kind of thing that's required to make things happen. If button is pressed, so and so happens. So you can imagine, if left is pressed, rotation changes one way. If right is pressed, rotation changes the other way. So let's get on with that next time. Tatty bye.